I think these problems are fairly simple if they're gravitational potential because there's no such thing as negative mass. Um, I think electricity gets a little bit more difficult. Let's just take a look at this. So we've got a 35 joules per kilogram at point A, right? And then point B, notice, is at a higher potential, right? Well, in gravity, if it's a higher potential, it just simply is higher, okay? So 89 joules per kilogram, right? Okay. In a vertical distance of 2.50 meters, what is the field strength and what force does it exert on a 23 kilogram mass? Does the field point toward B or toward A? Well, we can figure this out, right? If this is higher than this, right, gravitational fields point down, so it's going to be toward A, right? Okay, that's going to be the gravitational field. But what we're going to do here is we're going to use a formula here. So G is negative the change in potential, right, over the change in R, right? Okay, and then our change in potential from A to B is positive. What is it? It's final minus initial, right? So our final is this, our initial is this, right? So it's 89 minus 35, right? That's our change in potential, okay? And then R is that we went up 2.5 meters, okay? And then there's a minus sign in front of this, right? Okay, so that's where our direction is going to come from, right? We're going to get a downward force because we're going to get a negative number here. This is a change, the change of potential, that plus there says the change of potential is positive, but this minus sign is in front of everything, right? So here we go, 89 minus 35 is 54, and then I go negative 54 divided by 2.5, and I get negative, G is negative 21.6, right? And then this is joules per kilogram per meter, right? Right? And then the question is, what is that really? Well, remember, a joule is a Newton meter per kilogram per meter, right? And so the meters go away, and we end up with newtons per kilogram, right? That's what the units do, right? So our G is 21.6. Really, it's down, right? I just added that dimensionality of being down, right? It's definitely toward A, right? It's always toward. What this formula means is that the fields are toward the lower potential, right? They're the downward slope, right? Okay, and then what force does it exert on a 23 kilogram mass? I'm going to use G as F over M. So 21.6 newtons per kilogram is force divided by 23 kilograms. Oh, you poor children. The teacher has poor organizational skills. Okay, so times, I'm just going to multiply the thing on my calculator by 23, and I get 496.8. Ta-da!